Alright, pre-algebra class, this is lesson 32, the second video. We left off at this example, example 4. Example 4 has to do with example 4 on page 213. Nathan flips a coin 3 times. Predict what is more likely, that he will get heads at least once or that he will not get heads at least once. Find the probability of getting heads at least once, and then find the probability of not getting heads at least once. Okay. So first, A. Alright, well, if he's flipping a coin, remember a coin is either heads or tails. The probability of getting heads on one toss is 1 out of 2. 1 being that's what we want, 2 being the total possibilities, heads or tail. So it's 1 out of 2. Since the opportunity to get heads at least once increases with more tosses, we predict that getting heads at least once is more likely than not getting heads. We use a tree diagram to find the sample space. We find 8 equally likely possible outcomes. Okay, so he's doing the 3 tosses here. All right, so the first toss he's either going to get heads or tails. That's what this little tree thing is. On the second toss, he's either going to get heads or tails again. So after the first toss, where he got heads, he does it again. He's going to get heads or tails. Same thing with the tails. He's going to get heads or tails. Then you do the third toss. All right, third toss again. Heads, tails, heads, tails, heads, tails, heads, tails. And then these are all the possible outcomes. So you could have gotten heads, 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 the 3 H's. H, T, T. Okay, excuse me, H, H, T, right? H, T, H, H, T, 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 H, H, T, H, T, 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 H, and then T, T, T. Notice that we're walking along the lines each time. You're just doing all the possibilities. Okay, so here's all the possible outcomes. 7 out of the 8 outcomes have at least head once. So the probability of getting heads once is 7 out of 8. The probability of not getting heads is only 1 out of 8. If you'd only gotten tails each time, you would have not gotten 8. Okay. Alright, here's where we're going to distinguish between theoretical probability and then experimental probability. When I look at this theory, that is what you do when you before you even toss anything. Okay, you're not going to toss any coins. This is you're finding in theory what the probability of getting at least 1 H is. Well, the theory is that you get 7 out of 8. Experimental probability is actually doing an experiment. Okay, experimental probability is the ratio of the number of times an event occurs to the number of trials. For example, if a player makes 80 free throws in 100 attempts, then the experimental probability is 80 out of 100, or 4 out of 5. The player might be described as an 80% free throw shooter. Okay, so, but he actually did it. He actually did an experiment to prove his probability. Okay. That has to do with the batting average. Alright. Okay, let's go to example 5. Example 5. Emily is a softball player who has 21 hits and 60 at-bats. Express the probability that Emily will get a hit in her next at-bat as a decimal number with 3 decimal places. Emily's coach needs to decide whether to have Emily bat or to use a substitute hitter whose batting average is .300. Batting averages are usually expressed without a 0 in the ones place. How would you advise the coach? Okay, so we need to find out what Emily's batting average is. Well, Emily's batting average is, remember, these are it's from the previous. It's select all. Okay. So Emily's, she has 21 bats. So that's what she wanted. She wanted 21 hits out of the total, which is 60. So we can set that up. We can set that up as a fraction. 21 out of 60. And what you do with a fraction, remember that means division, just go ahead and divide it. If you divide it, you're going to get her average to be 0.35. Remember that we want to express this with 3 decimal places. Well, you just add a 0 there, so 0.350. Okay, so 0.350. So which is better, the 0.350 or the substitute batter, which is 0.300? Well, remember, to decide which is bigger of a decimal, you line up the decimals. here's a 3, here's a 3, no difference. Here's a 5, here's a 0. So this one is larger. That's a better batting average. So you would go with Emily because she has a larger. We advise Emily to bat. Okay. Let's move this. All right, so what I want you to do now is I want you to do the practice set. Practice set is A through G. A through G. I will go ahead and help you out on the first one here. Okay. All right, a number cube is rolled once. What is the probability of rolling an even number? Express the probability as a fraction and a decimal. Okay, number cube. Well, number cube, you got to remember that a number cube is 1 through 6. Okay, so you're going to have, okay, so you're either going to have a 1, 2, 3, 4, 5, 6. Okay, now express it as a fraction. So remember, the top is what you want. The bottom is what the number of total possibilities. How many total possibilities are there? 1, 2, 3, 4, 5, 6. Okay, there's 6 possibilities. Okay, how many are even numbers? That's what you want. Which one of these are even? Remember, we've talked about even before. Even and odd. Even numbers are the 2, 4, 6. Okay, so 2, 4, 6. How many even numbers do we have? 3. So there we go. There's the probability expressed as a fraction and a decimal. Change that into a decimal, divide 3 divided by 6, and you are going to get 0.5. So that's the answer to number 1. Okay, so go ahead and do A through G for this lesson. Okay, thank you. Good luck.